In this highlight video, we are going to take what we learned about naming of alkanes and we're going to apply that to cycloalkanes. So after we watch this video, you should be able to deduce the names of cycloalkanes. So for simple cycloalkanes, okay, so maybe we take 4 carbons and we put them in a ring. 4 carbons is butane. All we do is add cyclo. So this is cyclobutane. If we went to something like this, how many does that have? It has 7. So this is cycloheptane. Alright, so it's as simple as that. We just add cyclo to the beginning. As far as the general name layout, we're going to follow just like we did for alkanes. The only difference is that parent, we have the number of carbons, and we're adding cyclo onto that parent. Otherwise, we'll still have ane as the suffix for a hydrocarbon having only single bonds, and we're going to have our different substituents. The rules are similar, but not exactly the same. The first step is to find the parent cycloalkane, and then we're going to name and number the different substituents. If there's only a single substituent, it will automatically be at position 1. If we have more than one, we number the ring to give the first and second substituents the lowest possible numbers. If there's 2 different substituents, we start the numbering at the substituent that comes first in the alphabet. If we have greater than 2 substituents, we're going to number the ring to give the lowest substituent numbers all the way around. We write the name just as we did for the branched alkanes. Alright, so for the first example here, we have a 5-carbon cycloalkane. So this is cyclopentane. And we have only one substituent. Okay, do you know what this is? It has the branched methyl groups at the end. This is isobutyl. So we just write in isobutyl cyclopentane. So like I said, if there's only a single group, it will be automatically a number 1, and so we don't have to actually add that into the name. In the second example, we have a 6-membered ring, so it's going to be cyclohexane. But we have 2 different substituents, and we could number it 1, 2, 3 going this way, or we could number it 1, 2, 3 going this way, and so we're going to number it in the direction that gives the group that comes first in the alphabet the lower number. So let's look at our 2 groups. Over here, we know this is a methyl group. And over here, this is called a sec-butyl because it's attached to the secondary position of butane. Alright, so we're going to follow the numbering that goes in red because it gives the sec-butyl the lower number. Alright, so this is going to be, we have to give us numbers now. 1 sec-butyl, 3 methyl cyclohexane. Alright, let's draw a few structures based upon their names. This first one is similar to one we already did, so the parent is cyclopentane. So we just draw a cyclopentane, and we have an isopropyl group attached. So does it matter which position we put it at? No, we could put it at any of the positions. So I'm just going to choose it right down here because that position is automatically number 1. All right, the next one is a cyclohexane. You're going to get lots of practice drawing these hexagons in this class. And we have 1, 2, 4 trimethyls. We have 3 methyl groups. We can start wherever we want. I'm going to start here. 1, 2, 3, 4 trimethyl cyclohexane. All right, the last one is also a cyclohexane. 1 ethyl, I'll start over here again. 1 ethyl, 2, 3, 3 dimethyl cyclohexane. So is this correct? Is that name correct? Well, no, the numbering is not quite right, because if we have more than 2 substituents, we want to try to give the second group the lowest possible number. So if we start numbering over here, 1, 2, 3 in this direction, it puts the second group, the second methyl group, also at position 1. Okay, so this is not right. We are going to name this 3-ethyl 1,1-dimethyl cyclohexane. All right, so it's only different in the numbering. All right, so like before, keep practicing as many of these molecules as you can. Pretty soon the rules will just come second nature.